Okay, so the unit circle is a great tool for certain values that you're going to be expected to memorize. And so I'm going to start by filling in the degrees going around the circle. Start with the easy ones. So 0 degrees, 90 degrees, 180 degrees, 270 degrees. And then once we get all the way back around, we've got 360 degrees. Going around for these reference angles, we know that this is going to be 30 degrees. I'm going to skip over this one for now. 30, this is going to be 60 degrees, 90, 120 degrees. These are going up by 30s. Then 150 degrees, 180, 210. I'm skipping over these middle ones. And then 240 degrees, 270 is already there, 300, 330. Now I'm going to fill in these middles. So 45 degrees, jumping over 45, coming up by 45 is 90, then over here to 135 degrees, then 180 degrees, then 225 degrees, 270 degrees, 315 degrees, and then back around to 360. Going for radians now, we're going to follow a similar process. So I'm going to have 0 radians here. All the way over to here is pi radians. So halfway there is going to be pi over 2. So 0, pi over 2, pi. This is going to be 3 pi over 2. And then back around to 2 pi. Coming around, I'm going to just look at the ones that have 45 degrees as their reference angle. So we're going to have 0, this is going to be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Now I'm going to look at the ones that have 30 degrees as the reference angle, and I'm just going to care about these ones, even though I'm going to count some of the others just for reduction's sake. So this one here is going to be pi over 6 radians, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And by just writing those ones down, they're all reduced already. So now when I look at 60 degrees as the reference angle, this is going to be pi over 3 radians. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and back around. So now we've got all of the degrees and all of the radians around the circle. The next thing we're going to attack has to do with these points, right? Because any point on the unit circle, its coordinates are given by cosine of that angle, comma, sine of that angle. So let's start with our quadrantals. So out here, I know the point is at 1, 0. Coming up to here, I know this is at 0, 1. Out here is going to be at negative 1, 0. And down here is going to be at 0, negative 1. Now I'm going to fill in some of these other ones, but I'm going to start, as usual, by thinking about what quadrants we're in. So in the first quadrant, both the x and the y values are going to be positive, so the cosine and the sines of these angles are both going to be positive. Over here, the x values will be negative, so the cosine values will be negative. I'm going to put negatives in there. Down in the third quadrant, both the x and the y values will be negative, so both the cosine and the sine will be negative. So I'm putting negatives out front here before we even get to the values. In the fourth quadrant, x values are positive, y values are negative, so I'm going to put negatives where the sine values are going to go in the y. Now I've just got to fill in some values. Let's go for the easy ones. Any angle that is made with 45 degrees or pi over 4 as its reference angle is going to have square root of 2 over 2, square root of 2 over 2. So I'm just going to fill in these values. The sine and the cosine are going to be equal to each other because this makes an isosceles right triangle. Over here, At 135 degrees, or 3 pi over 4, that will also be square root of 2 over 2. Down here at 225 degrees, or 5 pi over 4 radians, square root of 2 over 2, square root of 2 over 2. And then over here at 315 degrees, 7 pi over 4 radians, square root of 2 over 2, square root of 2 over 2. Now we've only got the 30, 60, 90 special right triangles. And if I think about everything that's coterminal with 30 degrees, not coterminal, reference angle of 30 degrees, then I know that the cosine is going to be bigger than the sine. So the x is going to be bigger than the y, which means that this is going to be square root of 3 over 2, comma, 1/2. I'm going to reflect that over here at 150 degrees. Those are going to be the same numbers, square root of 3 over 2, comma, 1/2. Reflect that down here, square root of 3 over 2, 1/2. Reflect that over here, square root of 3 over 2, 1/2. And then for the ones that are missing, we've got the cosine is shorter than the sine because the x value is only coming over a little bit, but the y value is going up high. So this is going to be these reversed for everything that has 60 degrees as its reference angle. So this will be 1/2 square root of 3 over 2, 1/2 square root of 3 over 2, 1/2 square root of 3 over 2, 1/2 square root of 3 over 2. And then the last bit that we have in here are the tangents. And the tangents are the slope of the line that makes up the radius. So our easiest tangent is going to be starting out at 0, right? This radius here is horizontal, so the slope of that tangent is going to be 0. But this line is the same as this line, so this radius over here has the same slope. Coming to 90 degrees, we have a line with undefined slope, so this tangent is going to be undefined. But this is the same line here, so at 3 pi over 2 radians, this will also be undefined. These lines here have positive slopes. These lines here have negative slopes, so let's throw in some negatives. These lines here have positive slopes, so leave those alone. These lines here have negative slopes, so throw in some negatives. And then we've really only got 3 values, just like we only had 3 values for sine and cosine. The tangent will start with anything with a reference angle of 45 degrees is going to be square root of 2 over 2 divided by square root of 2 over 2. Well, that just means the tangent will be 1. Bringing this line back here to 5 pi over 4, the tangent of 5 pi over 4 is also going to be 1 because it's the same line. It's just a radius carried through. Similarly, if I'm coming from 135 on down, this is going to have a slope of -1, and so will 7 pi over 4. The last ones we have are going to have to do with, as we know, tangent is sine over cosine, so this is 1 over square root of 3. But once we rationalize that denominator, that becomes square root of 3 over 3. So this line here is the same as this line here, so they'll have the same slope. And then this other line right here, this purple one here, has the same reference angle, so it's going to have the same slope, just opposite sign, so SIGN sign. So this will be negative square root of 3 over 3, and carry that through to here, square root of 3 over 3. And then our last one is going to be square root of 3 over 2 divided by 1 over 2, which turns into square root of 3 over 1, or square root of 3. So the tangent of pi over 3, or tangent of 60 degrees, is going to be square root of 3. Bring that line back down here, same slope, square root of 3. The other quadrants, we're just going to have negative square root of 3. Bring that down, square root of 3. And that's how we fill in our unit circle tool.